So welcome, everyone. We're going to start. Welcome to the React Madrid user group. This is our first talk, as you may know. We're kindly hosted at the Flagship store, Escuela de Clientes, where they have 60 free online courses. You can check the website on the back of one of these sheets you have, one of these covers. And the aim is to give one talk a month. And if you know React and you feel like you have something to contribute, please step forward and or send us an email or send a comment or just propose a talk on our on the Meetup, and we'll be glad to have you. So afterwards, after this talk, we'll have beers downstairs. I'll talk about it right after the talk. But it'd be nice if you would all join. And without further ado, Miguel Molina, time traveling with React and Redux.
Okay, so we'll be talking about time traveling with React and Redux, as the title of the presentation says. Basically, we will go through 4 points. The first is what is Redux, what is its API, what it does, and what you can do with it. Then we will discuss how to integrate it with React. And then we will integrate the React dev tools to achieve time travel debugging. And finally, we will view an example of how to build a simple clone of the Twitter timeline with these technologies. And also a working version of the React dev tools, so you can see how the time traveling works in real life. So first thing, what is Redux? Kind of magic, you will see. So seriously, what is Redux? As they themselves say, Redux is a predictable state container for JavaScript apps. What does that mean? It means that is like a box where you store a state, because you know handling state is kind of complicated. In React, for example, you have the state, but it's you can achieve more if you only use the components as if it were pure functions with just receiving props and rendering an output. So it's better to store the state in another component. So this is where Redux comes in. And as you may know, Facebook, the creator of React, also released Flux with its theoretical kind of framework to build things with React. And sorry, oh, me queda en blanco. Sí, me quedo. Well, why Redux and not Flux, for example, or all kinds of Flux implementations like Reflux, or I don't know. There's like a ton of them. All of them are every day in the Hacker News. So basically, I personally like Redux because of 4 main things. One is it has a minimal API with a set of like a few functions. You can achieve everything you can do with, I don't know, the gazillion functions another Redux Flux framework has. It has a predictable behavior. That means that it's easy to test, that it's very important. Usually in the past, front-end applications didn't used to be tested, and that's a huge mistake. And with Redux, for example, testing is a lot easier. So it's if you don't want to test with Redux, it's because you're making an excuse, because it's really, really easy. And the last good point it has is it's not coupled to any framework. So you can use it with React, but you could also use it with Angular or Backbone or whatever you want. It's just a set of functions, and you can integrate it how you want. Redux has 3 principles. The first one is there's a single source of truth, that is the state. That is a tree object. in one place. For example, in Flux, you have many stores with many parts of the state. Here you have just one giant, or not that giant, state that is a JavaScript object, and of course one single store because you don't you just have one source. Second one is the state is read only, so it's kind of immutable, and mutations are only achieved through pure functions. So as you have seen, it embraces some concepts of functional programming, so that's good. Redux architecture is based on three kind of components. First are actions. An action is just a plain JavaScript object that defines that something happened. With actions, you can mutate the state. It's the only way of mutating the state. An action happened, and then the state mutated, and you have a new state. Then you have the reducers, that are the functions that are in charge of mutating this state. The reducers receive the action and the state you have now, and then after a series of mutation, they return you the new state. They can be composed, another thing of functional programming, composing functions. And finally, the store. The store is the component that holds the state. You may notice that I said store and not stores because of what I said is there's just one single store. It allows access to state, updates the state, register listeners, as usual. First, we will go through the actions. As I said, an action is just a plain JavaScript object. The only required thing it has to have is a type, because you have to describe what it is. It's just a string, like the identifier of an action. And the rest is up to you. I said post, but it can be whatever you want. It's just an object. That's not really part of Redux itself, but it's good to mention, because you can always create the literal objects whenever you want, when you want to create the state, but that adds a lot of boilerplate to your code. So to reduce the boilerplate, we can use action creators. Action creators are just pure functions that return an action. So instead of writing the whole object, I had to do blah, 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 you just call that function and you have your action. The reducers, as I said, is a pure function that receives the previous state and the action, and then returns the next state. We will see an example of a reducer. This is, for example, for a to-do application, for example. You get the initial state, that is an array if you don't have any state, and the action. Commonly, the common pattern to decide what to do is using a switch. So the action type, you switch over the types. For example, in the add to do, you do something and return a new state, and in complete to do, you do the same. You can see that we always return a new object. So to achieve immutability, that's the key of it. In ECMAScript 5, it was kind of harder to do that, but with the new spread operator of ECMAScript 6 and object assign, it's way easier. So now we can do that in an easy way. As I said, we can also combine reducers by just composing the functions. Redux has a function that is combine reducers, and you just pass an object to it. The keys of that object correspond to the keys in the root object that holds the state. So if we pass an object with foo, bar, and bas, foo reducer will be in charge of everything that is under foo, and bas reducer will be in charge of mutating anything that is under bar. And the store is the component that holds the application state. It receives a new action. It passes to the reducer, either a common reducer or combined reducers. And we can create the store with create store function. It's also a function of Redux. Here I import a full reducer from a file, and I create a store with that reducer, but it can also be a composed reducer using the previous function. It has 3 important methods. One is dispatch, is the one that dispatches actions. It receives one action, and then it dispatches the action to all the reducers. Get state to get the current application state, and subscribe. Subscribes returns you a function that when it's invoked will unsubscribe you. So here's an example. You subscribe, we pass a callback. So whenever the state is mutated, it will be called, and we will log the current state. And here we dispatch a simple action. So this code will log type add to do, text new to do. And that's it. That's really all the API you need for Redux. There's also middlewares for the store, but we won't discuss that. But it's also more function composition. So you have all the information on the API here in the official documentation. So now we're going to discuss how do we integrate Redux with React. We could, by ourselves, integrate it by using the functions that we've seen, subscribe, unsubscribe, dispatch, and get a state. But doing that every time is... And we can just use a package built by the same creators of Redux, that is React Redux. It's way easier to use. React Redux has a very simple API. Has a provider React component that has to wrap the root component of your app. That's not completely true. It has to wrap the root component where the descendants will need the store. But yeah, commonly just the root store. And it will pass the store down all your hierarchy using the React context. Right now, it has the children of the provider has to be a function. That has to do with a problem with context in React 0.13, and it will be corrected allegedly in 0.14. But for the time being, you have to pass a function, and then it will be invoked, and your root component will be created. There's also a funny bug with React Router that you can create inside the roots, but that's for another talk. And also the connect function. That is the second part of integrating with React. It's just a function that in which you specify which part of the state do you want. Because if you have, I don't know, the user account and products of a store and filters. If you're rendering a menu with user information, you don't need to get all the products and all that you don't need. So you can select only what you need. Here in Connect, I just select the whole state. So I receive a function. I make a function which receives the state and returns the state as it is. And then you invoke it with the component you want. And this component is wrapped in Connect, so we'll receive the store and everything that the object returns as props. There's more in the Connect API, but it's not that commonly used. So you can see here how it is. So we have a state like this, for example, an object with foo whatever and bar whatever. and we can subscribe to only foo, as I said, to just one part. By doing this, we receive the state, and we only return foo, because we only need foo for that component. That's the way we can split the state for each component. That's not really part of React Redux, but it's something of a recommendation. We have to distinguish two different types of components when we're using Redux and React. One are the smart components. These components are the ones that are connected to the store or subscribe, and will be the ones that dispatch actions. They will be the ones that hold the logic and pass it down the children. And we have the DOM components. DOM components just receive props and render themselves, how the parent says they need to be rendered. That's all they do. So in that way, we have all the logic in the smart components and all the view of the application in the DOM components. DOM components are obviously way easier to test, because you just have to pass props and see what the output is, and that's a good way. For example, we can imagine a catalog of products. We would have the catalog component, which is a smart component. It will be subscribed to the state, and we'll get the product. And also, it could have like the logic to buy a product, or to add it to the wish list, and it could pass it to the product component, and then it will be added to the wish list or whatever. And then we have the product component, which is the DOM. Just receives whatever data it has and renders a product, and that's it. And for example, if we passed the action of, I don't know, adding to the wish list, it wouldn't be contained the whole logic in the component. It would be in catalog. So we don't have any logic in there. That's an example. I don't know if it's, yeah. We have here the products. As you see, we connect to the state and return only the products of the state. We iterate over the products and convert them to the product component and just render them. Here catalog is kind of dumb, even if it's connected, because it doesn't do anything. But in the example, we will see a more complete demonstration of a smart component. And as I said, product is just renders itself. It doesn't do anything. So what about time traveling? We've seen that Redux maintains a state that it's only mutated through actions. So if we have an initial state and a stream of actions that have been happening on the app, we can get to the current state just applying these actions with the reducers. So that allows React through the Redux DevTools to time travel in debugging. We need to do two things to integrate Redux DevTools in our app. One is enhancing the store with a middleware, which I said we wouldn't discuss, but we will for that, and render a debug panel, because we have to see the debug panel somewhere. First, we have to import from Redux compose and create store functions. Create store, we've already seen it, but compose, I mentioned it, but we didn't talk about it. DevTools from Redux DevTools, the package, and our reducers. We have to create a function that is like create store, but with the middlewares applied. So we compose DevTools, and then we invoke it with create store, and we have a wrapped create store with the functionality of having the DevTools. So we finally invoke it to create our store, as we should do with create store, to create the store with passing our reducers. And then we just have to render the debug panel. before we render the provider just, and now we also render the debug panel. And that's pretty much it. The debug panel and such are inside the library. It has also a log monitor if you want to add it or not. In the debug panel, you can set where you want to render it. It's very, very configurable. So now it's the example time. We will see how to build a simple clone of the Twitter timeline, a really, really simple clone, because we don't have time to build Twitter here. It just will have the functionality of posting tweets, fabbing, and retweeting. Retweeting doesn't actually retweet, just adds the tweet you want to retweet to the top of the list with the button of retweet. And we will demonstrate how Redux DevTool works. Oh, and the source code is available on GitHub as soon as I release it, so we'll be there for you to see. Okay. In the first step, we create the skeleton. It's just a very basic index HTML and tons of configuration. You know how it's frontend these days. And we render the timeline with a provider, as we said before. We don't have DevTools here yet. It will be the last step we do. We import a timeline from components, which doesn't exist yet, but will exist. The store from store, which also didn't exist. So now we will create the actions. Now we have here the actions. Sorry. There are two kinds of actions. The actions that can happen in the form for posting, and the actions that can happen for a tweet. First, we will go through the form actions. There's just one that the input changed. So it's not very fancy. It's just a function that returns an action that says that input changed. Is a common pattern to use constants to define them, because strings are very tricky. And we just return that. I name it twister, so it will be twist and retwist and such, so don't get scared. It's not a typo, it's on purpose. We have three actions here. We have retwist, fab twist, and new twist. Retwist is just that, an object with the type and the ID of the tweet we're retwisting. Same with fab, and new twist is the same, but with the text. Pretty simple. Now we're gonna add the reducers. That's where the main logic is. The actions are pretty simple to create, but where all the logic happen here is in the reducers. No, step 4, no. Step 3. All right. So we'll go through the form reducers first. It's very easy because it just has one action. The initial state is just an empty object with empty text. And the action type, we go through the only case we can have that the input changed. And we use object assign to return the same state with the text change. We could also return a literal. It's the same, but just to illustrate how object assign works. And obviously, we can miss the default for the state because other actions can happen, and they are not handled here. They are handled in another reducers. This is the reducer for the twist actions. It's more or less the same. The state will be just an array of all the twists we have. When we fab a twist, we just made a map of the state we have right now, and we fab the one that matches the ID of the action. It's not very fancy. Map also creates a new array, so we don't have to use spread operators or anything fancy. For new twist, twist is a function that we will see later that just is a shorthand for creating the twist entity. We insert first, and then we use the spread operators to put all the twists in the state right now at the end. If you're familiar with functional programming languages, this is very, very common. And with retwist, we do exactly the same. We do a retwist, which is a function that returns the object entity of a twist that is retwisted, and we do the same. We append the rest of the twists at the end. Retwist actually searches for the tweet we want to retweet in all the state and uses the same object assign to have the same object we had with retwisted true and increment the ID, because we don't want the retwisted twist to have the same ID. And finally, twist, the only thing it does is create that object. Very simple. Now we will create the store and the components. I actually messed up with Git, so in this step there's the store and the components. So we'll have to imagine there's a step 5. In the store, as we've seen before, combine reducers, we combine twist. We don't pass the key because we name it twist and form. But if we want our state to have the keys twist and form, we will have to do that if we had another name, for example, twist reducer. We create the store and we export it. Now we're going to see the components. The form first, that is the most simple. We basically render a form with putting the color of the counter in red when the characters are more than 140, and we handle the onChange with is where happens the dispatch. We have here the dispatch with the action creator we created before, and we pass it the value. So this creates our action object, and then it dispatches it to the store. As we can see here, form is connected, so it's a smart component. It could have been a DOM component inside timeline, but we wouldn't have 2 smart components, and we wouldn't have divided the state, so I made it on purpose a smart component. We return the form because that's the only part we want. We don't want the tweets here because we don't need them. And basically that's pretty much it. On submit, we dispatch the new twist action, and we dispatch another action to clear the input. Then we have the timeline, which is also a smart component. In this case, we return the twist list. All we do here is iterate over the twist and convert them to the twist component. You can notice this. We pass it a function that is here. Why put retwist in here and not inside the twist entity? Because twist is not a connected entity. So we hold the logic in here, and then twist just does what we tell him to do. So we render the twist, and that's pretty much it. On fab, we dispatch the favorite action, and on retwist, we dispatch the retwist action, and finally the twist. We just use the props. We don't do anything. We don't hold any logic here. We just render the twist and use the functions provided. We don't even pass the tweet because it already knows it, because that logic is held in the previous component. So we don't have to do anything fancy. As you see, this is not connected. This is just a DOM component. Now the final step is to integrate Redux DevTools. Before we only render this provider, but now we also render the debug panel inside a div, because you can render to add the root component. And also there's changes in the store, which they are not. Oh no, it's because I didn't save that. All right, here. We compose the DevTools with create store, and then we finally create our store. That's just it. That's how easy it is to integrate it. And then there's that full demonstration of it working. It's basically the same with a lot of styling, just so it's fancy. We will see it working, so we can see how Redux DevTools works. First, we see nothing. We just see a form. So we say like, I don't know, hello. We can see here, that is the debug panel, how every time we type a letter, an action happens and the state changes. We can see here the action that happened with text and the current state at that point. So if we made a commit here, we commit the story, and then we say world. And I said, no, I don't like the word world. So I revert it, and I'm where it was before. That's how time traveling works. You can go committing the state, and then you can revert it, so it's really easy to debug. So we send a twist, we send another one, and we send another one. And I don't know, we retweet it. We can see here the fab twist action, then the new twist, and we retweet it, which a new one appears, and more fabs, and that's pretty much it. This is just how time traveling works. It's a very nice feature to have, because debugging is very easier than without this. So that's it. Go build awesome apps and embrace the power of Redux, and also the patterns that functional programming can offer to JavaScript, to JavaScript world. So thank you for being here, and we can have questions now. Yeah,
questions? I'll hand over the mic.
Which library did you use to test the Redux code?
What, sorry?
Which library did you use to test the code built with Redux?
To test, I used to use Karma, but now I use Mocha, because it's nice. Just that. More questions?
Which components has this dispatch function in the props? Only the smart ones? I mean, the ones that are connect?
Yeah, just the smart ones. The connect function, what it does is be a wrapper. So it returns. It has the store, and the store has the dispatch method. So what it does is pass that dispatch method as the props to the component that it wrapped.
And also, I imagine that it subscribes to the changes of the store and calls the render, or it's only, I know, it's only the main one. I mean, the provider is the only one that calls the render every time the state changes.
The provider, what it does is render what it has inside. That in this case is the children, the root component you pass to it. So every time the state changes, is provider the one who forces a new render.
And how do you think about using this immutate JS or something like that to avoid render the whole thing?
For small apps, it doesn't really make sense because you won't have any performance issues. But when you start having performance issues, you have to be more careful about methods from making the component update. And yes, immutable JS makes it a lot easier. I've used it, and I would totally suggest it for large code bases.
And it's a good couple with Redux.
What?
It makes a good couple with
Yeah,
Redux.
it makes a really good couple because the reducers, you have to return something always. So when you use immutable JS and you make a mutation, it returns a new copy. So it's way easier. When you have very complicated structures of objects, object design is kind of a mess. And immutable JS leverages the pain of that.
Thank you.
More questions? We have loads of time.
Where do you handle the events? I didn't catch where you're going. Did you handle the events in the store or the UI events?
The events, you have to handle them in. I'll show you here. You have to handle them in the component itself, because are the components the one that need the callback as a property. For example, here in Twist, we have the button here. Where is the onClick here? That is the one that says the onClick. So you actually pass here the callback. But I don't know if you meant this or meant where you hold the logic of the event.
That's what I meant.
Okay. So we don't hold the logic of the event here. The only thing we do here is avoid calling the logic if it was already fabbed, but the logic we hold it here. This we pass it to the twist component, and it's the one it calls. Here is where you hold all the logic. You dispatch this action. That's all the logic you have to handle, because the logic of mutating the state is already in the reducer. So you don't have to handle that in any part of where it is the app.
Thanks.
More questions?
Hello, I am new at React and don't know it very much too yet. Where do you subscribe to events or to actions? Could you show us an example, please?
You mean the subscribe to the actions of the components or the actions of you dispatch to the store?
The actions you dispatch.
Oh, here. Where is the component? Here. You subscribe with connect. What this does under the hood is called the store subscribe method, and then it automatically unsubscribes you. But that's it. You don't have to manually call to subscribe and unsubscribe. If you didn't want to use React Redux, which you should because it does that all for you, you could also call subscribe and unsubscribe by yourself.
Okay, thank you.
Anything else? Questions? Okay. Well, thank you very much for assisting. As I said before, there will be beers. Yay. Non-sponsored, though. Sorry. They will be around the building. There's a bar, which is pretty okay, I guess. And so it would be great to see you all there. And see you next time. Thank you.